Hello and welcome back to Chemical Lists by Mr. B. In today's video, we'll be going through a very typical unstructured titration question, and I'll be providing you with a tool that would allow you to calculate and answer any unstructured titration question correctly with minimal fuss. So let's have a look at this question and get cracking on. Now, you're told in this question you've got a solution of metal carbonate which was prepared by dissolving 7.46 grams of the anhydrous solid, anhydrous meaning no water. So 7.46 grams was dissolved in water to give 1,000 centimeters cubed of solution. We're told that 25 centimeters cubed of this solution reacted with 27 centimeters cubed of 0.1 molar HCl. We've been asked to determine or calculate the relative formula mass of M2CO3 and thus the relative atomic mass of metal M. Okay, so I'd like to better interpret this through a quick sketch. So we've got 7.46 grams of M2CO3 and we've dissolved it to make 1,000 centimeters cubed of solution. So we've popped that into a volumetric flask. We've added water to it to make a solution of a total volume 1,000 centimeters cubed. Now, from this, we had 25 centimeters cubed of this solution, and so this is 25 centimeters cubed of M2CO3, and this reacted with 27 centimeters cubed of it's not 0.01, it's 0.1 of 0.100 mol dm minus 3 HCl. So we've got a titration question. So how are we going to tackle this question? Because this is what's happening and we're asked to work out what the relative formula mass of M2CO3 is and thus the relative atomic mass of M. Now, whenever you've got a question and it presents itself in such a manner where you've got limited information, it's important to use the acronym. And this is the skill I was talking about. EMMA. How does this help? Right? So E stands for an equation. We need to have a balanced symbol equation for the reaction taking place. So we've got M2CO3 reacting with HCl. So we've got a typical acid-base reaction. So let's start off with writing a balanced equation. M2CO3 plus HCl, because it's an acid-base reaction, we've got salt plus water plus carbon dioxide. Our salt will be our metal chloride. We don't know what the formula of the metal chloride is going to be. However, we do know that the carbonate ion is CO3 2-, and because we've got two of the of the metals, then that suggests that our metal will be a positive 1 ion, possibly something from group 1. If it's a positive 1 ion, then that must mean it's M+, and it means that our metal salt that we've made is simply going to be metal chloride, MCl, because chloride has a -1 charge, so it's just MCl. It's not M2Cl, it's not MCl2, simply MCl. So we've got MCl plus H2O plus CO2. Now that's the equation. It is, however, unbalanced and we need to proceed to balance this. So I've got 2 M's on the left hand side, I've got 1 M on the right hand side. Let's add a 2 to balance the M's. We've now got 2 chlorines on the right hand side, we've got 1 chlorine on the left hand side. Let's put a 2 in front of the HCl to balance the chlorines. And now you'll find that everything else balances out. We've got 2 M's on the left, 2 M's on the right. 1 C on the left, 1 C on the right. We've got 3 oxygens on the left, 3 oxygens in total on the right. 2 hydrogens on the left, 2 hydrogens on the right, 2 chlorines on the left, 2 chlorines on the right. Happy days, that's fine. So we've now ticked off the equation part. So, second part, M in Emma. What does the M stand for? Well, it stands for the moles. So let's identify what information I've been given. I know the volume of my metal carbonate that was used, 25 centimeters cubed. I know that I had 27 centimeters cubed of 0.1 molar HCl. What can I work out the moles of? Well, the only thing I can work out the moles of is the hydrochloric acid. Why? Because it's what I've been given the most information for. I've been provided with its volume and its concentration. So I'm going to start off by working out the moles of the hydrochloric acid. So we know that moles is equal to Vc. So that must mean 27 times 10 to the minus 3, because we have to convert decimeters cubed, multiplied by the concentration, which is 0.1, and it simply gives us should be 27 times 10 to the minus 4. Let's have a look. 27 times 10 to the minus 3 multiplied by 0.1, which gives us 2.7. Yeah, so that's the same thing. 2.7 times 10 to the minus 3, which is the same as 27 times 10 to the minus 4 mole. Okay, so we know that information. We know the moles of HCl. Okay, so we've ticked M in Emma. Second M, what does that stand for? Well, again, it stands for moles. But we can't really work out the moles from scratch because we've not got enough information. For example, we can't work out the moles of M2CO3 with just this volume. We can't work out the moles of M2CO3 with just this mass. So what are we going to do? Well, the second M in Emma stands for the moles using ratios. It's the moles of your second substance using ratios. So let's have a look. I'm interested in the M2CO3 as that is what the questions asked me about. But not just that, it's in my equation. We know that for every 1 mole of M2CO3, we've got 2 moles of HCl reacting. So if I know the moles of HCl, let's just move that out of the way so you can see that. There we go. So if I know the moles of HCl as 2.7 times 10 to the minus 3, then that must mean half the number of moles must be the moles of M2CO3. So 2.7 times 10 to the minus 3 divided by 2, which gives us 1.35 times 10 to the minus 3 moles of M2CO3 in. And that's in 25 centimeters cubed because we've just worked out the ratio in 25 centimeters cubed. But this isn't what the question's asking me. It's asking me to work out the relative formula mass of M2CO3 and the relative atomic mass of metal M. Now, seeing as I know the moles of my second substance of the M2CO3, and I've done that using ratios, I know that that's the moles in 25 centimeters cubed, not 1000 centimeters cubed as per the original solution. So we need to work out the number of moles in the original solution. So the moles of M2CO3 in 1000 centimeters cubed will simply be the moles that we've calculated already as 1.35 times 10 to the minus 3, that's in 25 centimeters cubed. And because we want to know that the number of moles in 1000 centimeters cubed, we're going to have to work out the factor, or rather how many times 25 goes into 1000, and in fact it's 40 times. So we're going to multiply by 40, and that will give us the number of moles in, so I need to divide that by 2 from before, yeah, multiplied by 40, and that gives us a value of 0.054 mole. So I've worked out the moles of my second substance in the original 1000 centimeters cubed of solution that we made. Okay, so I've got that tick. Okay, so what does the A stand for? Well, the A stands for anything else. What else? Whatever else the question is asking us about. So, yeah, I know it's a bit lame compared to everything else, but it is what it is. If you've got any suggestions for what that A might be, write down in the comments and let me know. Okay, so anything else? We're asked to work out the relative formula mass in this question and thus the relative atomic mass of metal M. So to do this, I know the number of moles in 1000 centimeters cubed, and I also know that in this solution I started off with 7.46 grams of metal carbonate. So I know that the relationship between moles and mass is equal to N is equal to M over MR. Therefore, MR, the relative formula mass or relative molecular mass, is equal to M over N. I know M, which was 7.46 grams, divided by N, which is what I've just worked out, 0.054. So we've got 7.46 divided by 0.054, and that gives us a value of 138.1 gram per mole. So that is the relative formula mass of M2CO3. We've worked out that part of the question. The second part of the question asked us to work out the relative molecular mass. So to do this, the relative atomic mass of metal M. To do this, so if we know that M2CO3 has an MR of 138.1 and we want to work out what the relative atomic mass of M is, let's remove the CO3. So let's do 138.1 minus, now the carbon is 12, we've got 3 oxygens, each oxygen which has a relative atomic mass of 16, so that's 16, 16, 32, 48, so that's 60. So 138.1 minus 60, and that gives us 78.15, and that's the grams per mole, the relative atomic mass, but that's of M2. So divided by 2, because we've got 2 M's in M2CO3, and we've got 39.1 grams per mole. So we've identified the relative atomic mass of M. Now, I don't believe this question actually asks us to identify metal M, but we can do. So seeing as I've just worked out what the relative atomic mass is as 39.1, if I look at the periodic table and we know that it's a group 1, we know that it's a positive 1 ion, so it's quite possibly something from group 1. And I look at group 1 and identify which element has a relative atomic mass of 39, was it 39.1? Yeah, 39.1. 39.1, it clearly matches up to potassium. So potassium is the answer here. Not that it's asking you for it, but it's there. Okay, I hope that was useful. Please do recognize the merits of using this acronym EMMA in the questions. And again, recognize that I've shown my answer in a very logical sequence of steps. And I truly do hope that was useful for you. Until next time, bye.